In this video, we're going to talk about how you can use the properties of logs to both expand and condense expressions. So I just wanted to briefly go over the three properties we're going to use here before we actually start using them. So we've got the product rule, the quotient rule, and the power rule. And all of these rules, because they're equalities and they're equal on both sides, they go both ways. So not only do you want to think about the fact that, when we have a log with things multiplied inside of it, they can expand to addition. We also want to think about the fact when I have two logs being added with the same base, I can condense them to being multiplied in a single log. So that's the product rule. The quotient rule is similar, but it's just with division and subtraction, right? When I have two things divided inside of a log, I can expand them to having their own log, but being subtracted. Same way, when I have two things being subtracted with the same base, I can condense them to a single log with the arguments, which is what's in the log, being divided. And then last but not least, the power rule says that when we have an expression inside of a log with an exponent on it, we can bring that exponent down to be the coefficient of the log. So we're going to start with the most basic example that shows all the properties of expanding a log. Because even though some of the ones we do are going to look and be more complicated than this, the base steps, the basic way you approach it remains the same. And we're going to do these things in a specific order, okay? When we are expanding, we're going to start with the quotient rule. That's what we're going to do first. Then we're going to do the product rule. Then we're going to do the power rule. Okay, we are going to strip every single problem down to just these three steps to make everything accessible. And I'm going to show you these three steps with an easy example first, and then we'll apply it to something more difficult. So right here I've got log base 3 of x squared times y divided by z. So the first thing I do is I look and see if I can use the quotient rule. And to see if I can use the quotient rule, I need to see if there's any division present. And we clearly do have division here, right? We have x squared times y divided by z. So the quotient rule allows us to take the numerator and put it in its own log and subtract from it the denominator with its own log. Okay, so we've done the quotient rule. We've taken any division and changed it to subtraction. So now I'm going to move to the second step on my list, which is the product rule. So the product rule says that any multiplication can expand to addition. So what I need to do is I need to scan my problem and see if there's any multiplication there. And if it is, I can take it and expand it to addition. So right here we've got log base 3 of x squared times y. Well, we have the expression x squared times the expression y inside of a log. So that's a place for the product rule. So we can take that and expand it to being log base 3 of x squared plus log base 3 of y. Okay, there's no multiplication happening inside of log base 3 of z, so it just remains the same. It just remains log base 3 of z. Last but not least, we want to do our power rule. So our power rule says that when we have an expression inside of a log with raised to a power, we can bring that power down as a coefficient. So what I do is I scan my problem and I see if any of my logs, any of my terms have an exponent on it. And the only one that does is my first one. So the power rule says that I can bring that exponent down. So my final answer is going to be 2 log base 3 of x plus log base 3 of y minus log base 3 of z. I've run through all my steps. I've applied all my properties where I can. Now, not every problem is going to need every property, but as the beginning example, I wanted to show every property. But I've run through my list. I've done them all, so I am fully expanded. There's no more expanding I can do. So here's the cool thing about this problem. Even though it looks much more complicated, right? We have a lot more going on here. The bare bones of it, the basic steps are going to remain the same 3 steps we just applied. Okay, we're going to take a look at the quotient rule, then the product rule, then the power rule. There's one thing we have to do here first that's going to change it up a little bit because we have everything being squared, right? Before we can start separating things out, we have to distribute in that square, right? When we need to think back to the property of exponents. When we have an exponent raised to an exponent, we multiply them, right? So, that would be x to the 6. So we're going to do that for each of the terms as our first step. Then we will apply our order of rules. So I'm going to start by squaring everything. We're going to have log y squared becomes y to the 4th. X minus 1 squared is just x minus 1 squared. Z minus 1 squared is just z minus 1 squared. X cubed squared becomes x to the 6. So now I have everything is just, one exponent, right? One single exponent. So we can start applying our rules. And the first thing we look at, the first thing we've been doing and we'll continue to do, is we're going to look at the quotient property. That's what we're going to start with here. So I scan my problem. Is there any division? Yes, there very clearly is. So I take the numerator, put it in one log, the denominator, put it in another log, and subtract them, right? That's how I expand out a fraction. So this is going to become log of the numerator minus log of the denominator. Okay, and you can put parentheses here to show that it's all in that log. So that's my first step. I've applied the quotient rule. I only had one division thing, so it's only going to separate into 2 different logs. Okay, next up, I'm going to look at the product rule. Okay, the product rule says that I take anything being multiplied inside of a log and expand it to 2 logs being added. So I actually have 2 sets of multiplication here, right? We've got y to the 4th times x minus 1 squared here, and then inside this log, we have z minus 1 squared times x to the 6th. Both of those expressions need to be split to addition. So we're going to have log of y to the 4th plus log of x minus 1 squared. Okay, that's this one being separated. And then minus log of z minus 1 squared plus log of x to the 6th. Now here's the problem. We need to showcase that this entire log, notice this entire log was being subtracted, right? That entire log being subtracted showed us that it was in the denominator. This says, hey, this is being multiplied together in the denominator. So we need this to say the same thing. We need this to say, hey, all of this is in the denominator. Because of that, we have to put parentheses here. I like to use brackets, parentheses would work, that really show that this whole thing is in the denominator, right? While we can expand it to addition to show that it's multiplication, we need to show that the multiplication is happening in the denominator of the fraction. And we do that by putting it in brackets. Okay, so you have to have those brackets there. It is a completely different problem if you don't. If you don't put the brackets there, you're implying that the x cubed is in the numerator. But it's not, so we put brackets there. Okay? The last thing we do then is the power rule. So for the power rule, that just says, again, you take any exponents on a log expression and bring them down. So, for example, this, we could not bring that 6 down because the 6 isn't on the entire expression. It's just on the y. Now, that's not something we have to deal with here, but I just did want to mention that. In this case, we can clearly see, all of the exponents are on the entire expression, so we can go ahead and bring them down, right? We'll have 4 log of y plus 2 log of x minus 1. Now you can either, if you want, you can distribute the negative sign in, so you can just have it be minus minus. That would work too. I personally prefer the brackets there, but both are mathematically the same, so both would be correct. So here we'll have log of, oops, I forgot the 2. 2 log of z minus 1 plus 6 log of x. And we're done. We did our checklist. We did the quotient rule, we did the product rule, we did the power rule. Okay, this one was a little different because at the beginning we did have to simplify the exponents, but that's kind of just like simplifying before you get started. Okay, you want to make sure each term has a single exponent. So now let's talk about condensing, going the opposite direction, right? We're going from multiple logs down to 1 log now. And the cool thing is the properties are the same, we just apply them in a different order. So this time we're going to start with the power rule, then we're going to do the product rule, and then lastly we'll do the quotient rule. Okay, but the same rules apply. They're the same properties, and we just start by scanning the problem and seeing what we can do. So first, the power rule. Now for condensing, the power rule is going to be taking any coefficients in front of a log and bringing them up as an exponent. Now we don't want to bring the sign with us, just the number. So this is going to become natural log of x plus natural log of y minus 1 cubed minus natural log of z to the 1/2. Okay, and remember anything raised to the power of 1/2, that's the same as a square root. Okay, so we have applied the power rule. Next, we're going to look at the product rule. So instead of looking for multiplication for the product rule, we're going to look at addition between logs. And here you can see I have these 2 logs being added. So via the product rule, they can be condensed to multiplication. So we're going to have natural log of x times y minus 1 cubed minus natural log of square root of x. You can leave it as square root or to the 1/2. Those are the same thing. So now we've successfully done the product rule. Last but not least, we will look at the quotient rule. Okay, wherever we see subtraction, we know that the first term is going to turn into the numerator and the bottom term will turn into the denominator of a division problem. So it will be natural log of the first term, that's supposed to be a 3, first term, divided by the second term. Okay, and we are done with this problem. We applied all the properties, we did them, we checked, we did them in order. Okay, this is a very straightforward one. We did end up using all properties, but it kind of just went in order, right? It made sense. But the cool thing is, even if we have one that looks crazy different, the steps are the same. We break it down to a problem. We look to see if there's any powers we can bring up. We look to see if there's any addition we can condense. We look to see if there's any subtraction we can condense. And once we've done those 3 things, we are done with the problem. So almost all of them will follow that path. There is one situation where we need to do something a little different. So I'm going to show you the most basic example of that and explain why we do it this way. So if I was to do this problem, I would start by looking for the power rule, and I don't have any coefficients here that I can bring up, so nothing to do with that. Then next, I would look to see if I can apply the product rule. I don't have any addition to condense to multiplication. So then last step is I look for the quotient rule. But here's where I run into a problem. We have 3 things being subtracted. So that's going to give me a big old stack of variables. We can't have that. We do not have a fully simplified expression if we have a fraction within a fraction. Okay, because realistically what this is it's x divided by y divided by z. We have a fraction over a fraction. We would have to, flip and multiply. And it's not pretty. It's not what we want. It's not simplified. So what we have to do to prevent this, because we don't want this, is from the start, we need to factor out a negative. So what that's going to look like is we're going to have natural log of x minus natural log of y plus natural log of z. Okay, you can see that these are equivalent, right? If I were to kind of redistribute the negative sign back in, I would end up with what I started with. But now I can read this in such a way that instead of it being a fraction over a fraction, I've got two things multiplied in the denominator, right? Because product rule would first tell me to condense this to natural log of y, z. Then quotient rule would tell me to condense this to x over y, z. And that is what this means, right? You have to keep in mind that whenever we are condensing and expanding, we should be able to go the opposite direction and get the same answer. That's what we're looking for here. Okay, so this is a very, very simple example, right? There's nothing else going on here of something we're going to have to do in harder examples. Whenever you see multiple subtraction signs in a row, that means that all of that stuff is multiplied together in the denominator. So let's take a look at a kind of trickier example that puts that idea into action. So here we've got log base 7 of x minus 1 plus 2 log base 7 of y minus log base 7 of x divided by 3 minus 4 log base 7 of y plus 2. Now, before we go through our list, we have to simplify this and put this in a way that we can actually use our, product power quotient rule and method. The first thing I'm noticing is this is whack. That makes no sense, right? I don't know what that means. I need to rewrite that in a way that makes sense. So think about this. X divided by 3 is the same thing as 1/3 times x, right? 6 divided by 3 is the same thing as 1/3 times 6, right? So I'm going to rewrite that piece, that term, as 1/3 times log base 7 of x. So minus 1/3 log base 7 of x. Okay, the other thing I'm going to fix is that I have that minus there. So I'm going to put brackets to show that I'm subtracting this whole thing, but they are actually being added together. Okay, now that I have fixed those two things, not really fixed them, rewritten them in a way I'm familiar with, I can move forward with my list, right? First things first, I look at the power rule, okay? Power rule tells me that I need to bring up these exponents. So that's what I am going to do. I'm going to have log base 7 of x minus 1 plus log base 7 of y squared minus bracket log base 7 of x to the 1/3. It's not a very good 3, 1/3 plus log base 7 of y plus 2 to the power of 4. Then, after the power rule comes the product rule. So when I have things being added, logs being added, I can condense their arguments into a single log with the arguments being multiplied. So I'm going to take these two and turn them into a single log with the arguments multiplied. So we'll have log base 7 of x minus 1 times y squared minus log base 7 of x to the 1/3, which is technically, we can write it like this, cube root of x times y plus 2 to the 4th. Okay, I've done product rule, done power rule. Last but not least, I need to do quotient rule. right? I now have two terms being subtracted. You only want to use quotient rule when you simply have two terms being subtracted, because then I can take the first term and I'll make that my numerator, so x minus 1 times y squared. I take my second term, I make its argument, the denominator, cube root of x times y plus 2 to the fourth, and then all of that is in a single log. Okay, and we are done. We went through our checklist. We simplified it into a way that makes sense. Okay, then we did the power rule, then the product rule, then the quotient rule. This is completely condensed.